All right, so we are ready to begin. Hello and welcome everyone to another session of the DataHour series. We are thrilled to be here with you this evening that is going to be full of action-packed learning. I am Samriddhi Chaturvedi, part of the data science team at Analytics Vidhya, and the chat moderator for this session is going to be Sahil. So for those of you who have joined us for the first time, a brief introduction to the DataHour series. So it is basically a series of webinars conducted by Analytics Vidhya, and it is led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. So we are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is data science in retail. So retail refers to the selling of goods and services to customers for individual consumption, as you all might be aware. And the key to retail is that after purchasing from the retailer, a customer consumes the goods and services and does not resell it. So in this data hour, Chaitanya will explain some common retail terminologies that you would have already heard about during your last visit to the Big Bazaar or something, and then proceed ahead to discuss some of the applications of data science in detail. I hope you're excited to attend this data hour session with us. And before we kick things off and I hand it over to a speaker, a couple of things that I would like you all to remember, that we are recording this session and we'll make the recording available in a few days on a YouTube channel. Also, please do use our Q&A section for asking any questions that you might have during the session. And thirdly, we will share a poll about the feedback of the session towards the end. So I'll request you all to fill it out. Now, on to a speaker. In this session of Data Hour, we have Chaitanya Agarwal with us. So Chaitanya is passionate about solving complex real-world problem statements using data science. And he did his bachelor's and master's from IIT Madras and is currently working as a data scientist at Shell India. He has 6 years of work experience, primarily in the retail domain. A very warm welcome to you, sir. So over to you, Chaitanya. The virtual stage is all yours.
So this session is about use cases of data science in retail. I am Chaitanya Agrawal, data scientist currently working with Shell Business Operations in Bangalore. So what is retail? So let's talk in the common terminology. I believe almost all of you would have visited shops in your neighborhood from your childhood only. So if you visit to a shop to buy a grocery from a local grocery store, you are taking part in the retail transaction. So basically you are buying some goods from a business owner for your own consumption. So this is simply retail. And what is retailer? The shop owner who is selling the goods to you, he is a retailer who is retailing the goods to you. So retailing it includes all the activities involved in selling goods or services to the final consumer for personal non-business use. So retailer, retailing are almost like interconnected. So let's go to the next slide. So types of retail. Here I'll cover 3 important and I would say most commonly known types that you would have seen in your daily life. First is traditional trade. So traditional trade is a mom and pop stores that you find in your neighborhood, whether it be it a grocery store, whether it be a pharmacy store, or any other store which is operated by a single shop owner. He owns that store. So that is the traditional trade. It is also known as general trade. And traditional trade basically is available in almost entire country. In India, if we talk about India, it's present in tier 1 cities, tier 2 cities, tier 3, and villages as well. So traditional trade is ubiquitous. But now if we talk about modern trade, so let's take the example of India. It is DMart in Big Bazaar. But if you go to US, you'll find Walmart, Kroger, or if you talk about UK, there it is Costco. In Australia, it's Woolworth. So these are few of the examples of modern trade. So modern trade means they have a chain of stores from which you can go to any of the store if it is present in your city, and you can buy any goods and services which they are providing. So modern trade basically hasn't penetrated deep into our country, in India at least. It's mostly present in metros, tier 1, and some of the tier 2 cities. And so traditional trade has been present since eternity. Modern trade came into the picture later on. And latest entry to the scene is e-commerce. So any website like Amazon, Flipkart, Alibaba, they all are e-commerce websites, and e-commerce is also a type of retail where you can directly buy from the Amazon. So Amazon is doing retail trade with you here. Here again, you are the consumer, and Amazon is procuring goods from the seller. Basically, Amazon is a marketplace, but yeah, it is kind of a retail only. So let's move to the next slide. Here, let's briefly go through a use case of data science in retail. So why data science needs to be used in retail? Why we like what was the use case that was first envisioned? Like why people started thinking of how we can maximize our efficiency, we can maximize our revenue. So there's several use cases which are there in retail. So if you talk about your daily life, I believe uh, everyone would have used Google Photos. So Google does image classification there. Google can tag your images according to which person is there in the photo. Or you would use language translators. So language translator can translate any language X to language Y. So similarly, data science also has use case in retail. So think about the case if you are a shop owner or in traditional trade and you want to store some products in your inventory. Now, what happens if some of the product goes out of stock and a customer comes in and he asks for the same particular product? So you don't have the product, you can't sell that product to the customer. So you are facing out of stock problem. So data science can help predict out of stock. So if you are facing out of stock problem, you can
Sir, you are not audible. Your voice is breaking. I think there's some Wi-Fi issue at his end.
Uh,
So,
apologies again, guys. I think there's a lot of power cut issue today in Bangalore due to heavy rains. So, uh, am I audible?
yeah, sir, do you want us to share the screen?
Yeah, please, you can share the screen. Otherwise, it will be an issue again. It has been raining heavily since quite few days. So there are a lot of power cuts today.
No, no worries, sir. So, sir, Sahil will be sharing the screen.
Yeah, sure, please. Shall I share, Sahil, or are you sharing? Yeah. So I was talking about auto store problem with the retailers. So basically, this is one example where retailers can stock up the product based on the recommendations they get, and they can avoid out of stock issue and thereby reduce the loss of revenue that might happen. Second is recommendation engine. So if you shop on Amazon, you see, you search for a product, you get certain recommendations, and that's a recommendation built in within Amazon website. So it's also a part of use case of data science in retail. So you see, there are, like, I would say, infinite number of use cases. I couldn't list all of them. So here I'll talk about 4 use cases. First 3 use cases: space planning, market mix modeling, and order book preparation. I'll give a very brief overview of these 3 problem statements. In the fourth problem statement, trade promotion optimization, I'll focus much deep on this topic, which is I'll explain in the end. So we can start with space planning. Can you go to next slide? So space planning. I suppose all of you would have visited any mall in any of the cities. So what do you observe when you visit a mall? How is the layout of the mall designed? So let me ask a question. I believe I can see some answers on the chat. So why you think uh, food court and multiplexes are placed on the topmost floor of the mall? Can I see some answers from the audience? So yeah, correct. So Bijoy has given the correct answer. So people visit all the floors. So basically, that is the funda behind space planning. What a retail store layout designer wants to do is that he wants you to visit each and every floor of the mall so that there is maximum visibility given to all the stores present in the mall, thereby increasing the chance of a purchase. So if you are just going, if suppose you wanted to go to the mall, and mostly highest footfall is received by food court and multiplexes. So there is a high probability that if you enter a mall, you'll go to the topmost floor where food court is situated. Once you go there, you would have to pass through each and every floor. So you will observe all the surroundings of the mall, and that way it will maximize the sales for the mall owner. So what is happening here is objective what they're trying to solve here: maximize the time spent by a consumer within a store. So similarly to mall, you can think of any modern trade store like Costco, Walmart, Big Bazaar, D-Mart. If you visit any of the stores, you will find that the layout is designed in a very data-driven process. You won't find things placed here and there without any thought given to it. So there is some thought given to that, and based on the planning, all the SKUs are placed on the shelf. So space planning is basically the practice of designing retail store layout. So let's see techniques which you can use to design the layout. Once the designs are implemented, the layout is implemented, you'll see that there should be some increase in revenue, and thereby they take into consideration how much was the revenue gain, and then they adjust the retail layout accordingly. So this is a feedback loop which they follow. And let's see some of the techniques which are followed in space planning. So as soon as you enter the store, you first see decompression zone. So what is decompression zone? So decompression zone is a space which is situated just inside the door as soon as the customer walks in. So why decompression zone is necessary? So many people would think that it's a waste of space. There's no products. There are no products placed there. nothing is present, that space is blank. So what is the use case of decompression zone? So decompression zone is required because retailer wants you to enter the store and forget everything about the outside world. He wants you to focus on your shopping experience. He wants you to observe all the products placed in his retail shop or retail store, thereby increasing his margin. Because if you are focused on the shopping, you will buy things and it will lead to increase in revenue for him. So that's why the decompression zone is very much needed if you are planning to create a retail store. Second thing is food court and multiplex example I already given. Third one is the mall, he sees that some toys are placed on the lowermost shelf, he will definitely ask his friends, like, I want this toy. So if the product would be placed at the top floor, he wouldn't have been able to see the product. So that's why the placement is important, and it also comes under space planning. Fourth is most which is very attractive in the store. And the fourth one is complementary products. So complementary products, sorry, is my voice breaking? Just a second. Thanks for the feedback. So, okay, I'll turn off the video. I believe that will preserve the bandwidth. Okay. So the last example is complementary products are placed within reach for increased chances of impulse buying. So example, chewing gums are placed near cigarettes, bread is placed nearby butter. So these are the techniques used in space planning team to maximize the revenue, and it is one of the use cases of retail. Can we go to the next slide? So a second use case is market mix modeling. So basically, what is market mix modeling? Suppose you want to advertise some of your products. If you are a brand, you want to advertise some of the products. You do advertisement on TV, you do advertisement on print media, you do it on like YouTube ads. So there are various avenues where you can do advertisements of your product. You can do various kind of marketing and promotional activities to promote your product. So market mix modeling is a decision-making tool used by brands to estimate how much worthy was that marketing initiative which you took. So suppose I'm spending in 3 different marketing initiatives, and I want to see what was the return on investment on each of the marketing initiatives. So market mix modeling is a tool which helps you does that. So it breaks down the business metrics to differentiate between contributions from different drivers. So the drivers can be like print and media ad or digital spends or any other marketing activity that you would have done. And second one is the base drivers. So suppose a brand is doing no activity, no promotional spend, nothing, then also that brand gets sold. Why? Because that brand has built some brand value in its market. So customer knows that that brand exists. So incremental drivers help to propel the sales further, but base drivers can help business sustain the sales even though there is no marketing. If the brand has enough equity, enough brand equity, the brand has enough brand value in the market. So why MMM, which is market mix modeling, is required? What is the importance of it? So it helps the marketing guy to do better allocation of the marketing budget. It helps identify if I'm doing marketing using 3 different channels, which channel is giving the most revenue, or how much should I spend on this channel so that my return on investment is maximized. It also helps the marketing person to better execute the ad campaigns. So it all how much I should spend on each of the marketing channels to avoid saturation. And third, it also helps marketing person to do business scenario testing. So suppose if I increase my spend on this channel by 10%, how much will be the increase in sales? So market mix modeling is also a very common use case in retail industry. You will find each and every company doing it for their products because they want to maximize their spend. They want to maximize their ROI for whatever spend they're doing. So market mix modeling is a very, I would say, must to have product for every company who is doing retail sales. Let's go to the next topic. So retail order book preparation in traditional trade. So have you wondered how the order book is prepared of a grocery store which is present in your neighborhood? How that owner of the grocery store places order for the products, how the products are delivered? So let's imagine the scenario. If suppose today is 5th of September, it's the starting of the month. So I already have some products in stock in my inventory. Now by end of the month, some of the product stock would have got depleted. So what will happen now? A person from the wholesaler team will go to the retail shop. He will ask the retail shop owner for what items you want to place the order, for what SKUs within each category you want to place the order. So retail shop owner will give him all the quantities of each of the SKUs he wants to purchase, and retail sales representative will give some suggestions based on the trending SKUs in the market within that region. He will give some suggestions. It's totally on the retail store owner whether to buy those suggestions or not. So this is how the cycle works. Then the sales representative goes again back to the wholesaler and makes the delivery of whatever product that the order book had. But this process is not very optimized. You can see there are many inefficiencies. Shopkeeper may not know what all things are happening in the market, which product is in demand. Retail sales representative may not know what is the total how much sales any product is making for this in the same geography but in some other nearby region. So there are a lot of inefficiencies in the process. So retail order book preparation is a tool which can help sales representative to suggest to the shop owner that this much amount you should purchase for all these SKUs. So suppose some SKU X is very hot sold item in some other region. So this retail store order book preparation tool can give that insight by making use of data science. It can build all models, and it can basically give a good basket of products with how much quantity that the shop owner should purchase, so that the revenue of shopkeeper is maximized and also the revenue of the wholesaler is maximized. So this problem statement is an optimization problem statement in which the revenue is maximized by optimizing the number of SKUs within a category to be sold and quantity of each of the SKU to be sold by each store. So it suggests right mix of SKU based on seasonality. So if it's a rainy season, he will tell shop owner that you should stock this much item X of Odomos mosquito repellent. You should also stock this item, which is a very hot selling item in this region. So you should also stock it. It also can help shopkeeper to avoid out of stock in store issue, and it can improve the portfolio breadth of the shopkeeper. So this is how this tool can help shopkeeper maximize his sales, create a good order book so that the decision process is very much data driven. There's no like gut involved. Basically, the sales representative will give some suggestions. This process will not totally replace the sales representative and the shop owner relation, but it will be a decision augmentation tool. It will provide some support in the decision making that they are doing on day-to-day basis. So let's go to the next slide. Yeah. So let's talk about the promotions in modern trade. So can you guys identify what each of these promotions mean? Can you name all of the promotions that you see on the screen for each of these four pictures? Can I see some answers on the chat? Yeah, Niyas has correctly identified one of the pictures, buy one, get one. Shori also. So let me explain. So here on the screen, you can see four types of promotion. On the leftmost picture, you can see it is a display promotion. So basically, some items are placed on a secondary display apart from the regular shelves that you can see in a store. So it is a part of display promotion. This buy one, get one, everyone has correctly identified it. It is a multi-buy promotion. Third one here, half price, which we're seeing in the middle bottom, it is temporary price reduction, which is a discount of 50%. The rightmost one is feature promotion or catalog promotion. So here you see various products are featured in a newspaper advertisement or a pamphlet. So let's go to the next slide. So what are these types of promotion? Let's understand in detail. Temporary price reduction is self-explanatory. So for a temporary period of time, for a small period of time, the retail store provides some discount on the items. Like it could be 20% discount or 50% discount or any percent of discount. So this temporary price reduction, it is temporary in nature. You don't see half price throughout the year, because if store owner is pricing all its item at 50% discount throughout the year, it's no more a promotion. It's the price, it's the new price of the product. So for the promotion to work, the promotion should be offered in silos. They should not be offered throughout the year or very long continuous period of time, because otherwise then the promotion will lose its value. So this holds true for all kinds of promotion. So first is temporary price reduction. I hope everyone would have understood it. Second is multi-buy. This is also self-explanatory. So you buy two brush, you get one brush free, buy two, get one, buy one, get one, any type of combinations. Third one is feature and catalog. So you see pamphlets, newsletter, emails, any of this mode of communication where a product get featured about which informs customer about the promotions running in a store comes under feature promotion. And the fourth one is display. So basically display is the secondary placement of the product in addition to placement in aisles. So display, basically what it does, whenever customer enters a store, if it sees that some product is placed on display, it catches attention of the customer. So that's why display is placed. So if you visited any modern trade store, you would have seen many products placed separately in a corner or in some distinct location where you can very easily identify that product is placed on a promotion, because some special treatment is being given to that product. Let's go to the next page, please. So this type of promotions can happen with or without price decrease. So feature without display, display without feature, feature and display. This three kind of product promotions can happen with or without price decrease. So if a feature promotion is happening, it can happen along with price discount, or it can happen without price discount as well. So price discount is not a mandatory condition for this three: feature without display, display without feature, and feature and display kind of promotion activities. And the fourth one, price decrease only. Here only price decrease happens, no display, no feature, no multi-buy, nothing happens. So multi-buy is also one of the promotion types here. Let's go to the next slide. So trade promotion optimization. So basically, whatever we have talked about right now about the different kind of promotions, I wanted to give some background before we discuss trade promotion optimization. So that's why we talked about all the different types of promotion. So now let's talk about what is trade promotion first. So trade promotion is a marketing campaign which directly influence product performance. So it occurs in store to target direct shoppers actively making purchases. So market mix modeling is a bit different from trade promotion. So trade promotions you will see only when you visit a store. So if you're visiting a store, you see a product 50% on off. So you will see that promotion only when you visit the store. So that's what the second line means. So this promotions runs within the store and they target direct customers who are making active purchases within the store. So why trade promotion is needed? This multi-buy 50% off display feature, because you want to boost performance of products where some of the locations are underperforming. So there's a location where some products are not performing as per the expectations. So you provide some discount to improve the sales. Or you want to shift some established product into new markets, or you want to introduce new products into an existing market. So for various sorts of reason, you do trade promotion. Now, again, what is trade promotion optimization then? So to design the promotion calendar of an year, you need to know what kind of promotion I need to place in which month, or in which week I need to place what kind of promotion. This is not a random activity that you can place multi-buy on the 5th week of the year and then place display promotion on the 20th week of the year. It doesn't happen randomly. There's a science behind it, which is very much data driven. So trade promotion optimization is basically a data driven process which can help brand maximize ROI on their promotion spend. So brands spend a lot of money while doing this promotion spend. So this money, whatever promotion happens, is generally paid from the pockets of the manufacturer. So if you see any buy one get one or display promotion, there's a very high chance that for that promotion money came out of the pocket of the manufacturer, not the retailer. Sometimes retailer can also do promotions on it itself, by itself, but generally the promotions are paid by the manufacturer because they want to boost their sales and thereby increasing sales of every entity in the sequence, like wholesaler and retailer as well. So basically, trade promotion optimization tool helps key account manager, also known as CAM, to decide at what price to promote and when to promote. So TPO helps CAM to create price promotion calendar, or I would say promotion calendar. So according to Promotion Optimization Institute's 2019 State of the Industry report, CPG company spends between 11 and 20% of revenues on trade promotions. So 11 to 20% is a very big number. So if they're spending so much of their percentage of the revenue on the trade promotions, they would definitely expect a very high ROI on their investment. So while doing trade promotion optimization, we need to quantify the impact of each of the promotion types on total sales. So for example, if I'm doing any sort of promotion, what is the uplift in sales generated because of that promotion? You want to know that, because you can't randomly do the promotion. You are paying money for it. So you have to really you have to be very much data driven. So whatever type of promotion that you are going to do, you should know how much is the expected increase in sales that will happen, which will kind of be a return on investment for their money which I will be spending on the promotion. So to do the quantification of the impact, we study about sales decomposition, which is an essential part of trade promotion optimization. So trade promotion optimization itself is a very big tool, and sales decomposition is a very important module of this trade promotion optimization. So let's go to the next page. So what is sales decomposition? So suppose if I am the key account manager, if somebody asks me, no, so sorry, not key account manager, if I am the product owner, or I am the marketing guy, or I'm the person who is responsible for the sales of a product X. So if sales of product X is down, let's suppose some person within the company asks me why the sales of this product is down. I would say it is due to drop in advertisements, but the advertisement guy will say maybe the distribution of the product itself has come down, means the product is not readily available in the market. Or maybe some other person will say that maybe the pricing and promotions weren't good enough. So how do you get answer to all of these questions? So you can clearly answer all of this question by simply doing the sales decomposition. So you get the data, you would see how much uplift was generated by each of the promotion activities. You see who is the culprit here, what is the advertisement, or was it the fault of wrong pricing and promotion strategy, or the distribution itself was not present. So these are the answers which we get by doing the sales decomposition. So since there are multiple business drivers that impact sales, we need to understand how volume impact of each of these drivers can be quantified, right? So if we talk about mainly CPG industry, which is consumer produced goods. So it in the CPG industry, you have products like your hand cleaner, bathroom cleaner, sanitizer, soap. So all these products comes under CPG industry. So we have a database which is provided by Nielsen. So Nielsen is an agency or is a company which collects this data from all the retail stores about the promotion activities that are happening in a store, about the distribution, and they collect I would say hundreds of variables. They derive hundreds of the variables from the data they collect from the store. And Nielsen database help us to quantify all these retail drivers. Let's go to the next page. So let's talk about distribution. So if you are purchasing the database from Nielsen, you would expect that volume sales will be definitely present, because volume sales is a number one measure of how the product is performing. So in week one, was it just 100 units of sale, or was it 200 units of sale? So volume sales is definitely a number one measure, but the second most important measure is the distribution. So if your product is not available in the market at all, you give whatever promotions, anything, there will be no sales because the product is not there on the shelf at all. So for customer to buy the product, it has to be present on the shelf, right? That's why distribution is also a very important aspect of this analysis. You should know how much is your product distributed in the market, in which all retailers, stores it is stocked. Otherwise, there's no point of doing all this analysis if distribution data itself is not available. So how distribution is calculated by Nielsen? Basically, Nielsen supplies a variable named percentage ACV distribution, which gives us the distribution information. So it tells us percentage of stores selling our product, but this percentage is not simple weighted. It is not simple percentage. It is weighted average based on the product size, store size. So let's take an example. You see a table here. Let's say product X. We have 3 stores, store 1, store 2, store 3, and we have product X. Product X is being sold in store 2 and store 3, but it is not being sold in store 1. So if you want to calculate how much is the ACV distribution, percentage ACV distribution of product X, you will do 60 plus 80 divided by 180, which comes out to be 78%. So how this is calculated? Percentage ACV distribution, as I said, will be calculated for only those stores where the product was scanned at the counter. What it means, if the product was not sold at all, even though that product is in shelf or it's not on the shelf, but it wasn't scanned at the final counter, billing counter, if there's no data for the sale of that product, it will be counted as zero distribution from that store. So that's why here for the store 1, when there was no sale of the product or the product itself was not available on their shelf, it was not considered for the ACV distribution calculation, and that's how the ACV distribution came out to be 78%. So let's go to the next slide, please. So what is sales decomposition? Your total sales can be divided into two components. One is base sales and second is incremental sales. So what is base sales? So base sales is an estimate of sales that would have happened anyway if there was no promotion. So if there is no promotion, whatever sales are happening, those are base sales. But even though when promotion is happening, the sales that would have happened without even the presence of promotion is base sales. So I will clarify later on the next slide. I have a plot to clarify it better. But to simply understand, base sales is a sales that would have happened irrespective of whether the promotion would have happened or not. So it is similar to whatever base driver that we saw in market mix modeling. So what are the drivers of base sales? There are mainly 4 important drivers. First is distribution. Second is regular selling price, which in case it is known as MRP in India, seasonality and competitor impact. So if there's a good distribution of your product in the market, it will affect your base sales. Your price point of the product will affect base sales. The seasonality will affect base sales, like in the rainy season, sale of umbrella or mosquito repellent goes up. So seasonality affect base sales, and competitor impact also affect base sales, how your competitor is pricing. Let's go to the next slide. So incremental sales. So if let me first explain the base sales again through this plot. The plot you see on the right side of the screen. Here you see that week 3 has some sales which is quite higher than the week 1 and week 2. So in week 3 we did a promotion, that's why the sale was very high. Again in week 7 the sale was very high, and again the last week the sale was very high. So these 3 weeks were the weeks when there was a promotion happening in the store, and whatever is the extra sale which we are seeing is known as incremental sales. So even for the promoted week, 20 units of sale would have happened even if there was no promotion. So this 20 units of sale is a base sale for this week when the promotion was there in the store. Correct? So incremental sales happens due to the 4 promotions that we already discussed. So total units now can again be explained by another formula as well. So total units equals to incremental sales plus base sales, or incremental factor into base sales. So there's a reason why we have defined another formula. So incremental factor basically is calculated by doing a regression, which I'll explain in the next slide. So how it is calculated, incremental factor is equals to exponential of promotion type into its uplift coefficient. What is promotion type? So for the temporary price reduction, discount percent is the promotion type. So you will impute the value of discount percent and you will multiply by its uplift coefficient of the discount to get the incremental factor raised to the power of E to get the incremental factor for the temporary price reduction. For display, feature and multi-buy, you have ACV display only, ACV feature only, ACV display and feature combined, and you have ACV multi-buy. So corresponding ACVs of display, feature, and multi-buy, you will input here, and that will give you incremental factor for each of these 3 promotion types, right? So let's go to the next slide. So this equation is very important while doing sales decomposition. So what all things we see on this scale? I think the formatting has got messed up. So on the leftmost side, you see log of V. Log of V is the volume. So basically you want to estimate how much each of the drivers will affect the volume sales of your product. So P is the price of my product. CP is the competitor price. D is the distribution percentage ACV distribution. PR is promotion uplift. PR is promotion. It can be any type of promotion, be it multi-buy, discount percent, any kind of promotion. And CPR is competitor promotion. So basically, this all are the drivers we believe will affect the volume sales of a product. So if, for example, if you see, I think many of you will get the reference. Maggi noodles is sold in India by Nestle. So I think a very long back, 100 gram of pack of the Maggi noodles used to cost around rupees 10. Then slowly 70 gram of the packet used to cost for rupees 10. Then same 70 gram of packet was sold for rupees 12. Now it is being sold for rupees 14. So you see what has happened here. Nestle company kept on reducing the size of the Maggi product by keeping the price constant. So we can have a coefficient, a variable for pack size also, or the size of the product also. If you think that is also a driver, the change of the driver can change the volume sales. So you can include any kind of driver in this equation if you believe that will impact the sales of your product. So what this regression equation gives us? It gives us elasticity coefficient. So I think the formatting got messed up. So B1 coefficient is the own price elasticity. B2 coefficient is cross price elasticity. So what is elasticity? Let me explain that first. Elasticity is percentage change in volume for percentage change in price. So everybody knows that if brand increases price of a product by, let's suppose, 10%, it will directly affect the sales, volume sales of that product, right? So how brands make decision how much price increase they should do so that their volumes are not affected to an extent that their revenue goes down. So this is a very data driven process. Brands look at the elasticity of each of their products, and then they decide how they should increase the price of their product or how much promotion they should do. So basically, own price elasticity means when you do changes in the price of your own product and you want to judge its effect on the volume, you will use own price elasticity. Now, if suppose a competitor product of the same type is doing any changes in its price, it will also affect your sale. Because, for example, if a competitor is pricing its product, it decreasing the price of its product from 10 units to 9 units, then that product is now has gotten cheaper. So definitely your sales will go down because he is providing a discount on his price. So his product sales will go up. So cross price elasticity helps us calculate that. Distribution elasticity, I have explained many times, like if you increase your distribution or decrease your distribution, it will affect the volume sales of a product. Similarly, promotion uplift. So here you can do add all types of promotion. You can judge the effect, how much uplift each of these promotions are doing. So promotion also you can add, and also the competitor promotion. So this regression equation, you see, it's a log linear equation. So log of V, which is volume, equals to log of price, competitor price, log of distribution, and but promotions of competitor and the own product are not logged. Why it's so? So if you see, if you take partial derivatives of the volume with respect to price, first own price, it will give you dv by dp. So basically it will give you the formula of elasticity, which you see on the bottom right. So when you do a partial derivative of this regression equation with respect to each of the variables, you will get the coefficients, and to get elasticity, you need to do delta v by delta p into p by v. So this calculation happens automatically if you do log linear regression here. So b1 is the elasticity coefficient. So I will give one more example. So let's suppose milk is one of the products. So elasticity can vary from minus infinity to plus infinity mathematically, but in practical terms, it varies generally from, I would say, -5 to +5. There's no any hardcore range I can define, but average, or you can say it differs from -5 to +5. So if you decrease your own price, volume will go up. So B1 coefficient, which is own price elasticity, the sign of it is negative. But if competitor increases its price, your volume will also go up because your product has become comparatively cheaper. So the coefficient of B2 is positive. So like this, you can derive the signs of each of this coefficient as well. And that will help you understand how each of these drivers are affecting your volume sales, right? Let's go to the next slide. So this is the last slide. So let me present a scenario. Let's suppose there's an item for which we are doing this regression analysis, and there was no price change in the entire modeling period history of that product. So if there's no price change, you cannot calculate the elasticity of that product, right? Because to calculate the elasticity, you need to know what was the price change, and corresponding to that, you can calculate volume change. So because of the constant price of a product throughout the modeling period history, you cannot calculate the elasticity coefficient. So how does CAM will make its decision on price changes for this product? How he can make an informed decision if there's no elasticity present for this product X? So to solve this problem, what you can do, let's suppose you buy a hand cleaner of rose fragrance of 250 ml. And for this product, you see that the price change happened quite frequently in the past. So you see earlier it was sold for, let's say, 100 rupees. Now it being sold for 80 rupees. And now after some months, you would have seen it was sold for 120 rupees. So there's a fluctuation in the price throughout its history. But another product, maybe lime fragrance, was sold. Sorry, I got it opposite. So rose fragrance, there was no price change at all in history. But for the lime fragrance, there was constant change. There was continuous change of price in the history. So what happens then? You see that both kind of hand cleaners are exactly same for you. You can buy rose fragrance also. You can buy lime fragrance also of the same pack size, right? So the price is also same, just the fragrance is different. So for you, or for the key account manager, the elasticity of the lime fragrance will almost be same as the elasticity of rose fragrance, right? So if you do not have the elasticity coefficient for the rose fragrance, you can substitute it with use of lime fragrance elasticity, because in its price history, there was a continuous change in its price. So that's how you can copy variables. You can copy coefficients from the similar products which are there in the market. So if suppose this product would have not also seen the price change, you can pick another similar products. So there's a hierarchy of products. First comes the country, then comes the retailer, manufacturer, segment, brand. So there are hierarchy, if you don't find any replacement for your coefficient in the same hierarchy, you go a one level up. If the replacement is not present in that level as well, you go one level up again. So I agree that as you keep going one level up and up, the elasticity will not be a totally match for both the products, but it will at least provide you some decision point to make a conscious data driven decision. So this is how you can do substitution of the coefficients if you haven't got the coefficient from your equation. So this concludes my presentation. I think I explained all the concepts clearly. Apologies again for the continuous disruption that happened because of the loss of Wi-Fi. So I believe this session was informative and useful to all of you. So any questions that I can take up?
Okay, sorry to interrupt, sir. So before we take up the questions, I'll be sharing a poll and I would request you all to fill it. Thank you, sir.
Okay, sure.
Yes, guys, you can please ask the questions if you have any. There are two questions, I guess, in the Q&A section.
So Saurav has asked why we are using log-log regression and why using logs for elasticity. So basically, as I explained through the equation, log of volume equals to, let's suppose, constant plus a into log of price. This is the equation, right? So if you do a partial differentiation of this equation, you will get exactly the formula of elasticity, and that's why log-log regression is done. So basically elasticity is defined as percentage change in volume divided by percentage change in price. So the coefficient that is present along with the price variable, that coefficient gives you the elasticity if you do log of volume equals to log of price plus constant. So this is why log-log regression is done. Any other question?
Yes, sir. There are three more questions in the Q&A section.
Okay, I was looking the chat, sorry. Okay. We cannot classify B2B business as a retail business. No. So in the regression formula, why are we taking log to adjust the scale? I think I just answered that. Which data science algorithm apart from regression can be applied in retail sector and how they are implemented? So in the recommendation engine, which I talked about in the very beginning, you can apply like any algorithm, XGBoost, random forest. So there's no like I would say limitation of the algorithm. So there's another very important and very common problem statement is demand forecasting. So the Big Bazaar in India is a retail chain. So they want to know how much demand, they want to estimate the future demand, right? They want to know how much stock they should stock up. So to do the demand forecasting, again, you can use any type of algorithm depending upon the quantity of the data and the relationship between the variables within the data. So there is no limitation on the type of algorithm you can use. It depends upon the problem statement. For this sales decomposition, regression is used. But if you talk about any other problem statement, you could have used any other algorithm as well, depending upon the use case. Any other question?
Okay, guys, so are there any more questions or should we wrap up? Okay, I guess so. There are no more questions? Okay. So thanks a lot, sir. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.